We're starting off tonight's movie with a slide that I don't want you to write. It's just setting the stage for why we're doing what we're doing. English is actually a pretty poor way of communicating in a consistent fashion. So let's consider the following. When gasoline burns, it takes oxygen in and produces a mixture of carbon dioxide and water vapor. Carbon dioxide and water vapor are produced when gasoline burns with sufficient oxygen. Combustion of gasoline produces water vapor and carbon dioxide while taking in oxygen gas. The reality is this same reaction has been written in words 3 different ways, and if I wanted to, I could just keep writing it in a variety of other ways which are increasingly inefficient. So what we want is we want to make a more efficient way of writing things, which is faster and simpler for everyone. Let's have a look. So now we got our title, which is Writing Chemical Reactions, and we're going to go over some of our formatting. So first, reactants are the materials we start with. And so if we're writing a chemical reaction for making a sandwich, the reactants would be things like bread, meat, cheese, things like that. In contrast, products are the things that we make. So reactants are the things we start with, products are the things we make. In this case, the sandwich. Most chemical reactions will have somewhere between 1 and 3 reactants and 1 and 3 products. So they could have more, but most of the time it's 1 to 3 for each. Moving on in 3, 2, 1. There are some symbols that we're going to use, and these aren't chemical symbols, they're symbols for writing the reaction. First off, reactants are separated from products by an arrow. So an actual arrow showing the direction movement from reactants producing products. Reactants are separated from each other using plus signs, and products are also separated from each other using plus signs. Moving on in 3, 2, 1. There are 3 different types of chemical reactions or ways we write them. The first is a word equation, and word equations use words to show the reaction, but they use the pluses and the arrows for formatting. So that reaction we looked at the very beginning. Gasoline plus oxygen gas, arrow, produces carbon dioxide and water. That's our word equation. The next version is a skeleton equation, and skeleton equations use chemical symbols in place of those words, and still uses the pluses and the arrows. So gasoline will be replaced with its symbol, oxygen gas with its symbol, and so on. Now it's getting even more and more compact. So our gasoline is that C8H18, so that right there is gasoline. And the other chemicals, the oxygen gas, the carbon dioxide gas, and the water vapor, we recognize those symbols fairly easily. Moving on in 3, 2, 1. Some chemical reactions we want to include the state of matter because it is important for certain reactions to know what state of matter everything is in. The states are shown as subscripts in parentheses. Parentheses are round brackets, and that comes after the substance's symbol. We usually don't do it with a word equation, but quite frequently with skeleton equations. So G for gas, L for liquid, S for solid. Those make a lot of sense to us. The next one, AQ. AQ stands for aqueous, which means that the substance was dissolved in water. And those are the 4 standard states that we were going to work with. Our same chemical reaction, that C8H18, that'll be a liquid, plus the O2 gas, produces carbon dioxide gas and water vapor. So now we're adding more and more detail in a very compact form. Moving on in 3, 2, 1. The last reaction type I'm just going to introduce to you now, and we're going to spend more time on this in a few days. A balanced equation starts with a skeleton equation, which means we're using symbols. We're going to add something called coefficients in front to show the ratio of the substances needed for the reaction. So how many molecules of one thing versus how many molecules of another. When we properly balance the reaction we've been talking about, it turns out we need 2 molecules of that gasoline to combine with 25 molecules of oxygen. That produces 16 molecules of CO2 and 18 molecules of H2O. And the reason for that is if we carefully count all the atoms on the left-hand side and on the right-hand side, we'll find that we have exactly the same number of carbon atoms on the left and right, same number of hydrogens on the left and right, and same number of oxygen atoms on the left and right. And that's what we're going to be working towards later on. But in the short term, we're going to work on word equations and skeleton equations, and we'll build up later on to balanced. And we'll get that in another movie. Thanks for watching.